Okay, let's continue. Okay, this is 5.1. Let's continue into 5.2. What are we talking about in 5.2? A function has a unique behavior called one-to-one function. This is unique, guys. If you don't go into computer science, you like to have a function is one-to-one, is unique. What you put in, exactly one thing to come out, and that one thing to come out, it must be unique from one thing to come in. So in other words, if you want the function to behave something like this, you have an output and the input. Every input go to one output. Okay, so this is one to one. What we don't want is something happen like, well, first of all, this is, if a function behave like this, it's not a function. Okay, ah, these, if you have one thing go into two things, it's not a function. Okay, it's not a function. And also, if something is not one-to-one, what that mean is I can have something go here and some other thing go there too. So this is a function, but not one-to-one. Okay, but not one-to-one. What that mean here is one thing go there, another thing go there, but if whatever this thing here, I don't know where it come from uniquely. So it just doesn't have a unique idea what that means. Okay, one-to-one give you a whole lot of idea what that means. So we can actually test what one-to-one function is. Okay, we can test one-to-one function by check for horizontal line test. Okay, if it passed the horizontal line test, it is one-to-one. If it passes the horizontal line test, is one-to-one. What does that mean here? If you have a graph, simply a parabola, and this one, if a horizontal line test across two things, it's not one-to-one. What does that mean is, if I plug ones in here, you get one. If I plug ones in minus one in here, I also get one. That's not one-to-one. That's two-to-one. Two things can get into one. So that's not a good thing. Okay, you want one-to-one, it has to behave something like this. Yeah. This is passing horizontal line test all around. So this is a one-to-one function. So anything that you pass a horizontal line test will give you a one-to-one function. But why do we care about the one-to-one function type of behavior? Now, one-to-one function tells you a whole lot about the actual function itself, because it can tell you the idea of inverse, the concept of an inverse function. Okay, what is an inverse function? Definition of inverse function. What is the definition of an inverse function? So we denote as f minus 1 of x, so those are not a power, is an inverse of f of x when, if and only if, okay, by conditional, that f of f inverse of x give you x, and f inverse of f of x it also give you x. So if you have any type of those functions, it is a one-to-one. Means that I put x into f, I get, and then put back into an inverse, I get back to itself. So another way, just think about how to get back to the original state of a function. Okay, how to get back to the original state of a function. But we can check this. If a function have an inverse, these have to be true, and it's also that f of x and f inverse of x is one-to-one, and also, and if it's one-to-one, f and f inverse of x pass horizontal line test. It's important that this thing here is a key to find what you need. Okay, find what you need. So how do I find an inverse function? Okay, how do I find an inverse function? But before we do that, it's very good to understand what is the, when you talk about function, you talk about domain. So here, if you have this as domain of f, So that means if you map it to something else, and this one here called the range of f, okay? But you have to map this back if you want to go back to original. This is an inverse, so that means this is the domain of f inverse, and this is the range of f inverse. Okay, so that means you can think about this as the reverse process of get from one to another. Okay, there has some property. Okay, if there is a property, if it's a function is one-to-one and you want to find an inverse, it's just the reflections along y equal to x. So if you draw y equal to x, okay, if a function have an inverse, okay, let's say this function here have an inverse, like here's this function here, one-to-one. So what is an inverse of this function? If you look something like this, it have a symmetric along y equal to x. Every y go to x, every x go to y. So this is the inverse operator for this guy here. Okay, so that means in terms of graph, that's what it means. But how do I find it f inverse if I give you a function? So example, find f inverse of the following: a, f of x. Okay, if f of x is equal to 2x minus 5. So how do I find f inverse? Step 1, okay, let y equal to that function. Step 2, replace x by y and y by x. So here's what I meant by that. Step 1, write y equal to 2x minus 5. Step 2, every time you see y, you write x. Every time you see x, you write y. Okay. Step 3, solve for your new y. Okay. Now solve for y. Add 5 to both sides. This would have 2y equal to x plus 5. Divide 2 to both sides. That means your new y must be 1/2 x plus 5 over 2. So this is your new inverse. So that means f inverse of x must be 1/2 x plus 5 over 2. That is how you find an inverse function. If there are any way you get plus and minus or something like that, that is not an inverse. There's no way to find an inverse. So let's try another example. How do I find the next example? If I give you a different function. That's f of x, part b here, equal to 1 over 2x minus 5. Okay, so what is a y is equal to 1 over 2x minus 5. Now transform this into x equal to 1 over 2y minus 5. Okay, how do I deal with this? Well, change this to a 1 and then do cross multiply. It should be the same. That means you have x times 2x minus 5, 2y minus 5 equal to 1. Then I can want to get rid of this x, so I'm going to divide by x to both sides. So this is 2y minus 5 equal to 1 over x. Add 5 to both sides. You have 2y equal to 1 over x plus 5. That means your y is equal to 1 over 2x plus 5 over 2. So this is your inverse function to your new one. Is there a way that I having problem of finding stuff? So there's something a little bit harder. For example, C, if you have a function that dealing with such as x plus 1 over 2x minus 1. First, you write y equal to x plus 1 over 2x minus 1. So how do I change this? Now I imply this is x equal to y plus 1 over 2y minus 1. Again, the same cross multiply. This equivalent of saying x times 2y minus 1 equal to y plus 1. Now again, multiply this out. This is a 2xy minus x equal to y plus 1. Now remember, we solving for y, so our y term go to one side and non-y term to the other side. So So move this to this side. This is 2xy minus y equal to 1. If I move this to this side, is plus x. Now here I can solve for y. So this is 2x minus 1 over and 1 x plus 1 or 1 plus x. I can write either way. Y equal to x plus 1 over 2x minus 1. Wow, nice thing is this function has itself as an inverse. It looks very unique, very unique. Okay.